All right, so today we are starting off with a little operation with radical review. So here all we're doing is we're doing a little refresher of all the different types of simplifying of radicals and performing various operations, multiplying and adding, subtracting, like we did in the first semester. So the first problem that we see is simplifying the square root of 75. So our goal here when we're simplifying a radical is we're looking for pairs of the same number underneath the radical. For every pair that we see, we can pull out both of those values and we write 1 on the outside to represent the pair that was underneath. So to help you see what I'm saying, let's look at the square root of 75. So the first thing that I recognize is that 25 goes into 75. Right? We know it's divisible by a perfect square. 75 is divisible by 25, a perfect square. So I can see that it's 3 times 25. And 25, a perfect square, right? That's 5 squared. It's 5 times 5. So here's a pair of 5s right there underneath the radical with a 3 that stays behind. It does not have a partner to help pull it out from underneath the radical. So I'm going to write this, my final answer simplified, 5 root 3, or I could read that as 5 times the square root of 3. Okay, next I'm looking at negative 5 times the square root of 54. So here I usually underline the negative 5, right? I don't want to forget about it, but now I want to simplify the square root of 54. So 54, if I'm looking for a perfect square that goes into 54, I should see that that's going to be 9, right? 54 is 9 times 6. So 9 times 6. 9 gives me a pair of 3s. 6 I could break down further. I know it's 2 times 3, but there's not going to be a pair of the same thing when I break it down. So I'm just going to circle it right here. So now I have negative 5 times 3, and then that 6 stays behind underneath the radical. So in its final form, I have negative 15 times the square root of 6, or negative 15 root 6. All right, next up I'm having you add two radicals. You can only add two radicals when their radicands match. So when the number underneath the square root is the same, then we can combine them. And here we have that. We have 1 root 7 plus 1 root 7. So I really have 2 root 7s. It's just like when you add x plus x, those are like terms, you would get 2x. For D, when I stare at that, square root of 2 plus square root of 3, right, they do not have the same radicand. One is a 2, one is a 3, and I can't simplify each individual component to make the radicands match. So we're actually done here. This is perfectly simplified. Let me just acknowledge that, simplified. So my final answer just stays put, square root of 2 plus the square root of 3. There's nothing else I can do to simplify that any further. Okay, next one here, I have 3 root 40 minus 7 root 90. So here we're adding or subtracting, so we need the radicands to match. So when I look at each term, I see, oh, well, each one can simplify further. So if I look over here on the left, I'm going to underline that 3. Square root of 40, that's 4 times 10. And that 4 is a perfect square. It's going to give me a pair of 2s. Okay, there's nothing I can do with the 10. There's no pair in that. So I really have 3 times 2 root 10. So 6 root 10. That's my first term simplified. And then I look over at the second one. I'm going to underline that negative 7 so I don't forget about it. And then 90, I know that's 9 times 10. So 9 gives me that pair of 3s, and that 10, even though it's a 5 and a 2, it's not going to give me a pair of the same thing. So I really have negative 7 times 3 root 10. So negative 21 root 10. So I've gone ahead and I've simplified each of the individual terms. 6 root 10 minus 21 root 10. The radicands match, so I can keep going. I can say, well, what's 6 minus 21? And that's negative 15, and then root 10. Okay, for F, now we're multiplying. So when I'm multiplying, I combine the radicands. I put them underneath the same radical, and then I'm looking for my pairs from that point on. So if I'm looking at the square root of 6 times itself, right, what happens is those two 6's join underneath the same radical, right? So it's like saying the square root of 6 times 6. That gives me my pair right here, and my answer becomes just 6. So now let's extend that a little bit further. So now in G, I have square root of 45 times the square root of 20. So even if I don't put that little times notation here, that is what it reads as. So I can still put them underneath the same radical. And then I'm back to looking at my pairs. So when I look at 45, I know that's 9 times 5. Gives me a pair of 3's right here. That 5 does not have a pair yet. So now I'm going to look at the 20. And the 20 I can see is 5 times 4. That 4 will give me a pair of 2's. And these 5's right here are going to join forces together and give me one more pair of 5's. So there's really nothing that's left behind. My answer is going to be the product of 3, 5, and 2. So if I multiply 3 times 5, that's 15, and then times 2, I get to 30. Okay, for the next one here, same type of problem. We're multiplying, but now we have coefficients. So really, when I read this, it reads as 5 times the square root of 18 times negative 1 times the square root of 28. So I can reshuffle this in any way that I would like. So I would probably rewrite this first as 5 times negative 1 times the square root of 18 times 28, just like that. So I've moved my coefficients out in front, and now my radicands are together underneath the same square root. And now I'm looking for pairs. So for 18, I recognize 9 times 2. That 9 will give me a pair of 3's. Okay, for 28, I can see 2 and 14. That will help me scoop up a pair of 2's, and that 14 is a dead end, right? 2 times 7, there's no pair in that. So I'm just going to go ahead and circle it. So now when I multiply this out, 5 times negative 1 times 3 times 2, and then that 14 stays behind underneath the radical. So 5 times negative 1 is negative 5, times 3 we're at negative 15, times 2 we're at negative 30, and then root 14. That's our final answer. All right, we have 2 more. All right, for I, here I have 4 root 3 as a quantity squared. So here I have to remember that what that's really telling me is 4 root 3 times itself. And if I do that same reshuffling, this would be the same as saying 4 times 4, and then root 3 times root 3, and I can go ahead and combine them underneath the same radical. So here that's going to give me a pair of 3's. So this becomes just 4 times 4 times 3, and it will get me 48 overall. Okay, last one, J, I have to distribute that square root of 2 over the 3 terms that are in the parentheses. So I'm going to show that I have to distribute like so. So when I multiply the square root of 2 times 10, I get 10 root 2. When I multiply root 2 by 3 root 2, well, that's like saying 3 times root 2 times itself. It's going to give me a pair right there. It's like saying 3 times 2, which is 6. So right now I have the 10 root 2 plus 6. And then lastly, multiplying the root 2 times the negative 1 root 6. So I know it's going to be negative 1 or minus, and then square root of 2 times 6 like that. And then I'm just looking for my pairs. So 6 will give me a 2 times 3. Here's a pair of 2s. That 3 stays behind. So I get minus 2 root 3. So when I look at these three terms, I just want to think, is there more that I can do, or am I done? Well, when I look at those three terms, I do not see a common radicand. I do not see the number underneath the radical matching at all. Each term is perfectly simplified, so I'm done. This is as far as I can take it. This is as simplified as we are going to get. All right, that's all I have for today. Have a good rest of your day.